This is Calc I. This will be the first video. Is more of an introductory video before I actually do some math. That would be going to be the next video. And so calculus, Calc I is the course, and in summary, calculus is the mathematical study of change. In some areas, as far as where it's applied, it's very much applied in physics, engineering, and economics, etc. Especially physics, because that's kind of where calculus derived basically from Newton trying to study gravity, and he discovered calculus as a way of being able to describe how gravity works. But the three main topics for our course is limits, derivatives, and integration. It's the first 4 chapters of our textbook. Limits are chapter 1. Derivatives and their applications are chapters 2 and 3. And integrations chapter 4. And then we'll also be covering chapter 5, some bits of chapter 5. All right, so that's the overview. Now there's 2 main ideas for the course, and the first main idea is called the tangent line problem. And what I drew here is a curve, and that curve's the blue curve, and they might usually call it a function, and that function they usually call like letters F and G and so forth. But I'm interested in a single point that's on that curve, and that single point's point P. And if you notice, you see this green line that goes through that point P. That green line's called the tangent line. And a tangent line is basically a line that touches the curve at one point. So tan means touch, but it's going to be touching at just one point on the curve. And the idea is, if we can find the slope of that tangent line, it will give us the slope of the curve at that particular point P. And if we can find the slope of the curve at that specific point, that's called an instantaneous rate of change. So slope at a single point is instantaneous rate of change. So this is the slope of the curve at the point P. Again, it's instantaneous rate of change of the curve at point P. So the question is, how do we do this? And the answer relies on knowing the concept of limits. So the rough idea is that we can approximate the slope of this tangent line, or instantaneous rate of change of the curve at the point P, by using slopes of secant lines. And what I drew on the left here is so we still have our original setup with the blue curve, and then we have P and then that green line. And that green line is the tangent line. Now I added a second line that's in purple, and then a second point that's point Q. The purple line goes through the 2 points P and Q. Now P and Q are on the curve, so a secant line is a line that touches the curve at 2 points. So in this case, the purple curve touches the blue curve, or purple line, sorry, touches the blue curve at points P and Q. And the idea is, the closer I can get Q to approach P, point P, the better the approximation will be for that secant line to match the tangent line. So what I drew right here is a second diagram of the same thing, but in this case I drew Q as being closer to the point P. And you'll see that the purple line is mirroring the green line better than in the first picture. So the secant line, it becomes a better approximation as the point Q is closer to the point P. Now the reason why we're doing secant lines is because for a tangent line, it's only one single point that it touches the curve. And if you know anything about slope, slope is the formula is going to be m equals y2 minus y1 over x2 minus x1. And you'll see that I have two variables, x and y, but they have subscripts. One of them is x1, y1, and x2, y2. This uses 2 points. Slope uses 2 points. So how can I find a equation, or sorry, a slope of this green line that only touches the curve at 1 point? Since I need 2, we're using secant lines to have that approximation. And sometimes they call the slope of that tangent line of P, the green line, the slope of that green line is referred to as the derivative. All right, and finding the derivative means we need to know what limits are. All right, that's the first main topic or main idea that we'll cover. And just to recap, again, the setup was I have this blue curve and I want to find what's the slope of the curve or the instantaneous rate of change of the curve at this particular point P. Well, that's the same thing as drawing this green line that touches the curve at that point, and that slope of that green line, and the green line is called a tangent line because it only touches the curve at 1 point. The slope of that green line will give you the same value of the instantaneous rate of change of P on the curve. But since the tangent line only touches the curve at 1 point, and we want to find the slope of that tangent line, we have to have 2 points in order to find slope. So that's where we use secant lines. And a secant line is just a line that touches the curve at 2 points. And you can find the slope of that secant line since you have 2 points, and you can just plug it in the formula for slope. And the idea is that the closer Q, the second point, gets to the point P, the more closer the secant lines will mirror the tangent line. So the purple line gets closer and closer to resembling the green line for the second diagram versus compared to this one, the first one. You'll see that it's a better approximation when Q gets closer to point P. All right, and the slope of that tangent line at point P is referred to as the derivative. And to find the derivative means we need to know what limits are. All right, that's the first main idea. The second main idea is finding area under any curve. Right now, we already know how to find area of simple geometric figures. And by that, I mean like a rectangle. Area of the rectangle is length times width, or if you want to label it instead of length and width, you could call this base and height. It's just one variable times the other variable. So one dimension times the other dimension. Now for triangle, we know that's area is 1/2 times the base times height. And then we also know for area of a circle, that's pi r squared, or r is the radius. Now what calculus will do, once we get to it later on in the course, it will allow us to find the area of any curve on some specified interval. And by interval, I mean from a certain particular starting point to some ending point. And that starting point is A, and then ends at this point B. And in between those 2 points, I'm going to find the area that's below the curve, and that's shaded in green. All right, we'll find that we can find this area, and this happens for any particular curve that we can draw. So that's going to involve using what's called integration. All right, and in order to do the integration, we need to first know derivatives. All right, and again, so before we even know what derivatives are, we need to first know limits. All right, and integration, that's in chapter 4. And then this derivative stuff's chapters 2 and 3. And then what we'll be doing from the first part of the course is limits, and that's chapter 1. All right, so the integration is a technique that gives us an ability to find the area under any curve. So we no longer have to deal with these perfect geometric shapes like a rectangle, a circle, or a triangle. It can be any wacky looking curve. All right, so that's the two main ideas. One of them's called the tangent line problem, and the other one's finding area under a curve. And again, the overview is limits first, chapter 1, derivatives and its applications are in chapters 2 and 3, integrations chapter 4, and then we'll also cover bits of chapter 5. All right, and this is pretty much an introduction of the course, a broad overview. And in the next couple videos, before we start limits, we're going to go over just briefly algebra and some trig problems. So before we start limits, we'll go over a review of algebra and trig. That's going to be the next couple videos. All right, so I didn't do any actual math. I mean, everything I'm talking about is math, but I didn't do any calculations or stuff of that nature. That's going to be starting in the next couple videos. So first do algebra and trig. After we have a little review of that, then I'll jump into limits. All right, and this course, calculus, is not by any means an easy course. So say Calc 1. Not easy, it's not meant to scare you. It's just preparing you for what's about to come. And if you need any help, email me and I could do some tutoring, and we could do it through Zoom. All right, since the COVID-19 stuff is prohibiting us from being able to meet in person, I don't mind doing some one-on-one tutoring via Zoom. Just email me and we can discuss specific times, and I'll say the same stuff. It's going to be see the syllabus for my email. And I'll also have specific times that are called office hours. In the office hours, since I'm not really technically in an office, I'm just going to be around my computer at a certain time. And you can email me during that time, ask me a question. We can schedule a Zoom call. if I'm not already doing one with another student. Now I'm stressing this now because again, calculus isn't easy, and some people tend to wait till the last bit of the course to get tutoring. And by that point, they've already sort of not understood all this stuff that builds up beforehand. And they might not end up with the grade they want. And so to ensure the best grade possible, best performance, I encourage you to try to get tutoring as soon as possible. All right, and there's other sources. There's tons of things on the internet, and I usually use YouTube. And on YouTube, there's a specific playlist under this guy called Professor Leonard. I would YouTube Professor Leonard. He's got tons of stuff, and then look for his Calculus 1 playlist or Calc 2 playlist of something of that fashion. He's also got algebra and trig. So Professor Leonard's a really good person to look up on YouTube. Also, there's Khan Academy. Another source, there's a website, and he's also on YouTube, but it's patrickjmt.com. And he's got it broken up into topics like algebra, calculus, and then other particular math courses. So these three are the three that I used in college. And well, Professor Leonard's more of a new one, but I definitely used Patrick JMT a lot. He goes through problems. Professor Leonard will discuss the concepts. I mean, I'm going to discuss the concepts as well, but that gives you another point of view of somebody that you can refer to. And then obviously there's, so that's other resources, and then there's tutoring services online. And I believe if you do enough digging on the internet, you could probably find free tutors that are willing to help or at a low cost. All right, but like I said, I don't mind doing one-on-one tutoring. I'm going to have office hours. The main point is that you need to contact me as soon as possible, as soon as you believe that you need tutoring, or if it's difficult for you to understand, because we want to catch it early versus later on. All right, and that's it for this video. This video is meant as just sort of an introductory video. The next video, I'm going to go into actual math and do some algebra and trig review.